Now, what is Bayes' theorem? Bayes' theorem is a conditional probability. Now, suppose you have same as before, A1, A2, K as a mutually exclusive and exhaustive events, and the probability of AI for I from 1 to K is positive. For any other event B with the positive probability, the probability of AJ given B. Now, the probability of one of these events given that B has been occurred previously. Okay, we know the the definition of conditional distribution. So it's the intersection of the probability of intersection of AJ and B divided by probability of B. So we already obtained the probability of B by using the law of total probability. You know the probability of B. So we substitute the probability of B here, and for the numerator, by using the multiplication rule, we have the probability of AJ that then multiplied by the probability of B given that AJ has occurred before. So you can see in the Bayes theorem it's a conditional probability. B has occurred and we are going to obtain the probability of one of these parts in the sample space, for example AJ, and then it's by using the definition of conditional probability and substituting the multiplication rule and the law of total probability, we can obtain the formula for Bayes' theorem. Before you remember that we talked about this exercise in multiplication rule, but now we are going to solve it completely. At a gas station, 40% of the customers use regular gas, 35% mid-grade gas, and 25% premium gas. So you can see the partitions here. It's the gas station. It means it's S. You have 3 parts. 40, 35, 25. 40, 35, 25. Is a regular one. It's the mid-grade one and it's the premium one. So you can see that 40% plus 35% plus 25% is the probability of S. Now, of those customers using regular gas, only 30% fill their tanks. Event B. Now you have another event as a filling the tank. So this one you have another event like B, A1, A2, A3 is filling tank. So how we can show it as a tree diagram, the probabilities? Okay, we can see we have three kind of gas. The probability of A1 is 40%. The probability of A2 is 35%. The probability of A3 is 25%. Then of those customers using regular gas, only 30% fill their tanks. So here the probability of filling tanks, given that using A1, it means using regular one, is 30%. So the probability of beta prime, it means doesn't fill or a gas, is customer doesn't fill a tank, is 0.7. Then again here, the probability of filling gas, given that using mid-grade gas, is of those customers using mid-grade gas, 60% fill their tanks. So it's 0.6. So the probability of beta prime, given that A2 is 0.4. Again, and of those using premium, 50% fill their tanks. So again, we have the probability of B, given that using premium gas, is 50%. So the probability of B prime, it means not fill a tank, given that using premium gas, again, is 50%. So you can show all the probabilities in a tree diagram. Now, by multiplying these probabilities, you can obtain the probability of A1 intersection B by using the multiplication rule. So the probability of A1 and B, it means the probability of using a regular gas and filling tank, is the probability of A1 multiply the probability of B, given that A1. So 0.4 times 0.3. Again, the probability of A2 and B is the probability of using mid-grade gas and filling tanks. You know that at first you may make a decision about the kind of gas, and then you make a decision about if you want to fill your tank or not. So the first one is A2. It's the probability of A2, and then the probability of B, given that A2 has happened before. So the probability of using a mid-grade gas times the probability of filling tanks, given that using mid-grade gas is 0.21 the result, and for the third one is the same as first one and second one. The probability of using premium and intersection and filling tanks is the using premium, and the probability of filling tanks given that using premium gas, and the result is 0.25 times 0.5. So we have these three probabilities. Now, number one, what is the probability that the next customer will request mid-grade gas and, you can see the keyword, and fill the tank? Mid-grade is A2, fill the gas is B, and is intersection, so we want to we should obtain the probability of A2 intersection B. We have it here, A2 intersection B is 0.21. What is the probability that the next customer fill the tanks? Now you should obtain the probability of B. You should obtain the probability of B filling the tanks. So you should use the law of total probability, because you have to obtain the probability of B by using these parts. The probability of A1 intersection B, the probability of A2 intersection B, the probability of A3 intersection B, and we have all of them here. So according to the law of total probability, for obtaining the probability of B, we should just obtain the summations of these, the summation of these probabilities. So 0.12 plus 0.21 plus 0.125, and the result is 0.455. So if the third one, if the next customer fill the tank, you can see the keyword again, if. Is a conditional sentence in English, in literature. So if the next customer fill the tanks, it means if B has occurred previously, B is filling the tanks. So if B has occurred previously, it means we have this, if B has occurred previously. What is the probability that regular gas is requested? Regular gas is A1. So A1. Then if you compare this probability with this equation, you can see it's the Bayes theorem. If B has occurred, what is the probability of A1? So it's the probability of A1, probability of B, given that A1, probability of B. So, and this part is the probability of A1 intersection B, probability of B. Okay, we have both of these probabilities. Probability of A1 intersection B is 0.12 and probability of B is 0.455. So it's is the answer. Again, if the next customer fills the tank, what is the probability that mid-grade gas is requested and at the end premium gas is requested? So the probability of mid-grade gas if B has occurred, because if the next customer fills the tanks. So Bayes' theorem is a conditional probability. You should read the question several times to find the keywords. Understanding the question is very important. So it's the probability of A2 intersection B, and the last one, the probability of A3, it means premium gas, given that customer has filled the tank, is the probability of A3, probability of B. So the probability of B is 0.455 and this one 0.21. Now, another exercises. A students answer a multiple choice examination question that offers 4 possible answers. Suppose the probability that the student knows the answer to the question is 80% or 0.8, and the probability that a student will guess is 0.2. Assume that if the student guesses, the probability of selecting the correct answer is 0.25. So complete the following table. Okay. A is the event that a student guessed the answer. Okay, here if a student, the probability that a student guess the answer is 0.2. A prime is the complement of A. So the complement of guessing is knowing the answer. So A prime is 0.8 or 1 minus 0.2 is 0.8. You can see the result here. Even that B is the event that students answered correctly. So the probability of answer correctly if a student guess, A is guessing the answer. If a student has guessed the answer, so we have this if a student, if is the conditional probability. If a student guess the answer, the probability of selecting the correct answer is 0.25. So this one is 0.25 and the last one, the probability of B, it means answer correctly if a students know the answer. If a students know the answer, the probability of answering correctly is 1. It's a certain event, 100%. if you know the answer, you will choose the correct one. So this probability is 1. Now the second one, if the students correctly answer a question, if, again you can see it's the conditional probability, calculate the probability that students really knew the correct answer. At first, you should recognize in the question that you have partitions. So, there is 2 cases. You know the answer, A1, or you guess the answer is A2. 80% you know the answer, and 20% maybe you guess the answer. And another event is about the result. Okay, it means this one is B is choosing correct one. So, if you know the answer, with probability 1, you will choose the correct one. But if you guess the answer, because you have 4 choices in the question, with probability 0.25, it means 25%, maybe you choose the correct answer. You can see that 4 possible answer, and 0.25 is because of these 4 possible answers. So if we want to show it with a tree diagram, what happened? So with you have 2 cases, the probability of I want to use the notation as here, guess A, okay? The probability of A, it means you have guess and you have know. This one is A prime. The probability of A is 0.2. The probability of A prime is 0.8. Now you have 2 cases. And the probability of answering correctly, if you guessed it, answer, the probability of answering incorrectly, if you guess the answer, the probability of answer correctly, if you know the answer, the probability of answer correctly if you answer incorrectly if you know the answer. So because it's a multiple choice question with 4 items, so this probability is 0.25 and the probability of answering wrong is 0.75. If you know the answer, the probability of choosing the correct item is 1. If you know the answer, the probability of choosing the wrong answer is 0. Now we are going to solve the question. If a student's correctly answer a question, calculate that the students really knew the correct answer. So, if a student answer correctly, the probability that students knew the answer. So is the probability of B. So is the probability of A prime the probability of B, and here is the probability of A, the probability of, when you want to calculate the correct answer, okay, there are two cases. At first you guess the answer, it's the guess. You guess the answer, and the probability of answering correctly, if you guess the answer, plus the probability of you know the answer, then the probability of answering correctly if you know the answer. Okay. The probability of knowing the answer, 80%. The probability of answering correctly if you know the answer is 1. The probability of guessing the answer is 0.2. The probability of answering correctly if you guess is 0.25. The probability of knowing the answer is 0.8. The probability of answering correctly if you know the answer is 1. You can obtain the result. Be careful, here is plus. You should at first obtain the results here. So it's 0.8, and this one is 45 plus 80 is 45 plus 80 is 0.25. 1.25. So is the this question. So another one. I have a bag with 3 coins in it. One of them is a fair coin, but the others are biased coins. When flipped, the 3 coins come up heads with probability 0.5, 0.6, 0.1. This one is the fair one, and this one are biased. Suppose that I pick one of these 3 coins uniformly at random and flipped it 3 times. What is the probability of HTT? Okay. So you have 3 coins, and because you can, again it's the keyword uniformly. Because of this keyword, the probability of picking each of them is 1 divided by 3. So if I picked one of these 3 coins at random and flip it, the probability of HTT. The probability of HTT, there are 3 possible situation. The first one, if I pick the first coin randomly. The second one, if I pick the second one randomly. And the third one, if I pick the third coin randomly. So you have three coins, C1, C2, C3, and you can see the summation of this are 1. It means it's S. Now you should obtain the probability of HTT by considering C1, C2, and C3. So if I picked C1, then the probability of HTT in C1. If I picked C2, then the probability of HTT in C2. If I picked C3, then the probability of HTT in C3 is the law of total probability. So picking C1 is 1 divided by 3, but because C1 is a fair coin and the probability of H and T is 0.5, so it's HTT, it means the first one is H and second one T and third one T. So it means it's the multiplication counting rule. So it's 0.5 times 0.5 times 0.5. And again, if I picked C2, then the probability of HTT, given that I picked C2, the probability of H and T in C2 is 0.6 and 0.4. So it's 0.6 times 0.4 times 0.4. But if I picked C3, is again the probability is same as before, 1 divided by 3, but the probability of HTT is according to this information, the probability of H and T for the third coin is 0.1 times 0.9 times 0.9, and you should obtain the probability of HTT by using the law of total probability. Now the second one. Assuming that the three flips in order are HTT, this one has happened previously. It's the conditional probability. We have some prior information. We know that the result or the outcome is HTT. Now, by using or by awareing of this prior information, what is the probability that the coin that I picked was the fair coin? Look at here. Now you are looking for the probability of C1 if the result is HTT. It means if B is happened, what is, or HTT is happened, HTT is happened, what is the probability of C1? It's the Bayes theorem. It's the Bayes theorem. Okay, it's the probability of C1 intersection HTT and divided by probability of HTT. We already have the probability of HTT. We could obtain it by using the law of the total probability. But in the numerator, we have C1 intersection HTT, and according to the base formula is the probability of C1 the probability multiplied by the probability of HTT, given that C1 has peaked. So you can see it here. So this part divided by the total probability. So the total probability is 0.101, and in the probability of C1 is 1 divided by 3, and because C1 is a fair coin, the probability of H and T are equal, so it's 0.5 times 0.5 times 0.5, and it's the answer. Now look at this question, exercise 63. A professional organization sells term life insurance and major medical insurance. Of those who have just life insurance, 70% will renew next year, 80% of those will only have a major medical policy will renew next year, and however 90% of policy holders who have both type of policy will renew at least one of them next year. Of the policy holders, 75% have life insurance, 45% have major medical, and 20% have both. Now look at these numbers. 75% plus 45% plus 20% is more than 1. So these three parts are not mutually exclusive, because they have some outcomes in common. They have both of them. It means they have intersection. Now, number 1, calculate the percentage of policy holders that will renew at least one policy next year. Okay. We need, at first, before solving, we need the probability that we have just life insurance and the probability of just medical insurance and the probability of both. We want to make them disjoint. Just life, for example, if is two kinds of insurance, it's life, if medical, and this one is both. So just life is this part. Is just life. So 70% have term life insurance, but in this 70%, maybe there are some people that have, in addition to life insurance, maybe they have medical insurance. So just life insurance is 75% minus both. Both is 0.2 is 0.55. The whole life is 75. It means the percentage of people who have life insurance is 0.75, but we have some people that have both of them. Here is 0.2, so this part is 0.55. And for just medical, 45% have medical insurance, but maybe some people have both of them. So here is 45, so just medical is 0.25. So for here is 0.45 minus the intersection of life and medical is 0.25, and for both there is no problem, is the result is 0.2. Now we have three mutually exclusive and exhaustive events. Now we can write it. We have for example A1, A2, A3 is the life, medical, and both. So now here is 0.2, 0.25 and 0.55. So you can see that is 1 in total. Now we have another event like B about renewing the insurance in the next year. So we have another event like B for renewing the insurance in next year, and now we are going to obtain the probability of B. Look at here. Calculate the percentage of policy holders that will renew at least one policy next year. At least it means if they have one, they will renew the one. If they have two, they will renew both of them or one of them. So the probability of renew is the probability of, if I have just life insurance multiplied by renewing, if I have just life, plus if I have just medical, the probability of renewing if I have just medical. And then if I have both, multiply by probability of renew if I have both. So you can see that the probability of B, if at first A1 if I have life, then renewing inside life insurance. If I have medical, renewing inside medical insurance. If I have both, renewing inside the both insurance. So just life is 0.55, and according to the question, who have just life insurance, 70% will renew next year. So the probability of renewing inside the life insurance is 70%. So then just medical is 0.25, and and 80% will renew next year, so it's 0.8, and the probability of both is 0.2, and the probability of renewing is 90%. You can see here who have both, 90% of people who have both types will renew. So is 90%, and the result is 0.765, or 76.5% of people will renew at least one insurance next year. And the second part, if a randomly selected policyholder does in fact renew next year, what is the probability that he or she has both life and major medical insurance? Now it's the conditional probability. If renew, what is the probability of both? So if renew, what is the probability of both? So it's a Bayes theorem. It's a conditional probability. So it's the probability of both and renew, probability of renew, and according to the multiplication rule is the probability of both multiply probability of renew. If we have both, probability of renew, we have the probability of renew is 0.765, and this one probability of having both is 0.2, and probability of renewing if you have both is 90%, is 0.9. So the result is 0.235.